Example 4. Fairweather Airlines has a peculiar rule about luggage. It will accept only bags for which the sum of the length and width is at most 36 inches, while the sum of the length, the height, and twice the width is at most 72 inches. What are the dimensions for the bag with the largest volume that Fairweather will accept? Use the second derivative test to verify that your answer yields a maximum. So you actually have the word maximum there. Now, every time I start the problems, I like to look for what are the given or restrictions. And these are always the pieces related to the numbers that are in the question. So focus there, then I'm looking for the sum of the length plus the width is at most 36. So sum means to add, and for length we'll use L, width we'll use W, and we're saying less than or equal to 36 because of it saying at most. They're okay if you have a smaller bag. Next, again, we're finding a sum of length, height, and twice the width. So length plus height, twice the width, how do we write that? Yeah, it's 2W, not W squared. And again, less than or equal to 72 because of the at most. Next, I need to figure out whether I'm maximizing or minimizing this problem. And because it said largest volume, and just writing that in my notes, I know that I'm trying to maximize. And the volume formula is length times width times height. Now the problem is I want to maximize that, and I would be taking a derivative, but I have 3 variables and we don't know how to take a derivative for 3 variables. So I need to solve the other equations, not the volume, for 1 variable. So we'll go ahead and start with that first equation, length plus width equals 36. We don't want to deal with solving equations with inequalities because of potentially having to flip the inequality, and we really just care about setting it to a numeric value. So I'll go ahead and subtract the W over to get a single variable function where the length is 36 minus the width. Next one, length plus height plus 2W equals 72. Before I decide what letter I'm going to solve for, solving for L again doesn't help me because we actually already have a solution for L, right? We need to think of L as 36 minus W now, and then go ahead and clean up this equation. So we start with 36. We'll go ahead and combine our 2W terms. -1 plus 2 is positive 1W, plus H is the 72. Subtract 36 to both sides. And now I have W plus H equals, well, 72 minus 36 is 36. Now, again, it's tempting to solve for the W because it's first, but the thing to think about is we actually already have W as part of a value we're going to be plugging into. So if L equals something with W, then let's go ahead and also get W on the other side for H. If you didn't do it this way, you'll just have a couple extra steps of substitution and you can still get the right answer. But now that I have solved both of my restriction equations for 1 variable, I'm ready to go ahead and substitute or plug those into the function I'm maximizing. So taking the volume function that starts with the length, but instead of writing L, we're going to write 36 minus W. Next, we write the width, and we have not solved for a width, so we'll go ahead and just put the W. But in terms of height, we do have an equation to substitute height with, which also is 36 minus W. Now, my goal is to take a derivative of V. We know how to do a power rule, which you don't really need to, because let's go ahead and just distribute here. And then again, you could take the product rule at this point, but let's go ahead and either do FOIL, the box method, however you multiply this out, but you know we're going to have 36W times 36, etc. And after cleaning it up, we can see that, you know, our final terms will be a minus W squared times minus W to give me positive W cubed, but you can work that out. I now have a function that I'm ready to solve for maximizing. So I need to find the critical values of my V function, my volume, by taking the derivative. So the derivative of 1296W, of course, is just the 1296, minus 72W squared, so negative 72 times 2 is negative 144 to the W, and plus W cubed is just plus 3W squared. So I have my derivative. I need to set it equal to 0, but as you look at it, we tend to write polynomials in descending order of exponents, and then set it equal to 0. You could factor a 3 out, but even if you factor 3 out, your last term is going to be 432. Trying to find all the factors of 432 that equal whatever my new middle value is sounds like a pain. So I went ahead and just used the quadratic formula. And when I set this equation equal to 0 using the quadratic formula, I got values of 12 and 36. That should be a W, not an X, but I fix it a little bit later on. But what we care about is 12 and 36 are the two factors of that equation. So to use the second derivative test to verify which or both of those are maximums, I need to first find the second derivative. So I'm looking down here at my first derivative, and as you know, the derivative of 1296, since it doesn't have a W, is going to go away, but the derivative of negative 144W is just negative 144, and the derivative of positive 3W squared is plus 6W. So now I can test my critical numbers in the second derivative. My first critical number is a 12, and as I plug that in, I get, negative 72. What I care about is because it's negative, I know it's concave down, and that means I have a maximum, which, yeah, that's what we're looking for, the largest or maximum volume. Testing my other critical number of 36, I plug that in to my second derivative function, and this time I get positive 72, which, because it's positive, my function is in a concave up region, which means it would only contain a minimum, which is not what I'm looking for. So no, I don't want that. So now I'm ready to find the other values, right? I know that my width of 12 gives me the maximum I want, but I need to go back to the other equations. Remember, we still need to find the length, and so we had the length is 36 minus W, excuse me, and this is where I caught that, uh-oh, that was supposed to be a W. I plug the 12 in to get 24 for the length, and the same goes for the height. I also need to take what I solved the height for and substitute the W with the 12 for my maximum luggage size, and I am ready to write my answer. So we found that the maximum width comes when W is 12. Ooh, we have to write units on this. So as you reread the question, it just asks for the largest volume, so that doesn't really help me. But going back to the numbers, the 36 was in inches, the 72 was in inches, and because I'm finding a width that would be at most 36 inches, right? We can say inches. The length down here, we found that L was 24, so also inches, and the height also happened to be 24. So we've got our answer. Now the other thing is a side note. Some people say that when they got 36, oh, it's actually still circled, as a as a critical value, they knew that we couldn't use 36 because if you look over here, the length plus the width can only be at most 36. So if we plug a 36 in for here, this means the length would have to be 0, and you can't have a 0 length. But the important thing for us to know is that the calculus also proved to us that 36 was not the critical value to give us a maximum volume.